Hello everyone, my name is Jason Gregerson, and this video is going to be Introduction to doing linear algebra stuff with your TI89. So once you've got your calculator and you've turned it on, the first thing we want to do is be able to enter in matrices and vectors. So we'll start by entering them directly into the calculator. To do that, I'm going to hit F4, and I'm going to choose the first option by pressing number 1, which is define. I'm going to define alpha to get my A equal to my matrix. And to enter into this matrix, I'm going to use square brackets, so second and then this button to do square brackets. And then I'm going to enter in the different elements of my first row. I'm going to separate those different elements, those different components, by commas. So my first row might look like 4, comma, 5. And now I want to start a new row. So to go to my new row, I'm going to hit second and go to semicolon. So second and 9. That starts my values in my second row. My second row is going to be 0, comma, 1. That's all the rows I'm going to have. So now I'm going to close up my matrix with my other square bracket. And when I hit enter, it's going to store this 2 by 2 matrix into A. And if I want to call it again, I just enter in A and hit enter, and sure enough, there's my matrix. Now I want to enter in another matrix. This time I'll use a different technique. This time I'm going to go to apps. I'm going to hit number 6, or scroll down to number 6 and hit enter. That'll be my data matrix editor. I'm then going to choose 3 to start a new matrix. Once I'm bringing to this screen, I will select over and then down to select matrix. And I will scroll down twice and I have to find a name for my matrix. So I'm going to go alpha and I'll hit B here. So my matrix will be called the B matrix. And then I got to specify the rows and columns. I want mine to be a 2 by 1 vector, so that means it will have 2 rows and 1 column, and so I should be all done. Now I'll hit enter, and it will bring me to this window where I can put in values. My first value of my vector is going to be 2. I'll hit enter, and then 3, and I'll hit enter. And now I should have entered in my full value. From here I'm going to go to second and quit. And everything should be stored into B. To test it once again, I can choose my B and enter, and there's my vector. So now what do I want to do with my vectors? Well, I might want to multiply my vectors together. In this case, I can do I can do alpha A times alpha B. And sure enough, I have a 2 by 2 times a 2 by 1. The result should be a 2 by 1. And now I can switch the order and go alpha B times alpha A. And when I do this, it will give me a dimension error because I can't multiply these two matrices in this order. I will escape away from that. Now the next thing I might want to do is solve a system of equations. So if I take the matrix A that I've used to be my coefficient matrix, and I take B to be the B vector on the right hand side of my AX equals B matrix equation, then to solve that system I'm going to go to math, so that's second and 5 to bring math, and then I'm going to scroll down to matrix and go over, and really I can see several different tools are going to be valuable. I can take the transpose of a matrix or the determinant of the matrix. I could take my matrix and put it into REF or REF. This next one is simult. And this is how I'm going to simultaneously solve the different equations in my system. So I can choose this one, and then if I enter in my A matrix with a comma and my B vector for that right hand side vector, and I should be able to run this, and it will find the solutions to my system. So here are the solutions, the x1, x2 values that solve my system. Now, depending how the system is situated, I may not be able to get a solution depending if there's free variables and there isn't a unique solution to my system. So, one way to handle systems like this would be to look at the augmented matrix and do the row reduction. So I will go to second, math. I will go down to matrix, hit over, and what I want to do is go get a row reduced echelon form, but I want to do that of an augmented matrix. Now I need to go back to second and math and to 4 for the matrix, and now I want to select number 7, augment. This will create an augmented matrix where A is the coefficient matrix, and it is augmented with B. And I will close both these arguments with parentheses, and I'll run that. And here I can see the row reduced echelon form. And then I can use my linear algebra knowledge to extract the solutions from this, or to interpret the results here. Now, of course, there's many other operations I can do with my calculator. Once again, if we go back to that second math and then hit 4 for the matrix list, I can see I've already looked at determinant and that row echelon forms. Solving the systems, I can generate a n by n identity matrix. I can get a diagonal matrix where I put in a list of the diagonal values. We can find the eigenvalues and the eigenvectors, and LU decomposition, QR decomposition, and many, many, many other things. I can also, if I scroll farther down, do some vector operations. So if I select this list of vector operations, I can take cross products and dot products and do conversions and all other kind of things. Find unit vectors. So I encourage you to explore all the different options that are buried within this menu. For now, the other one I want to talk about is the eigenvalues and eigenvectors. So once again, if I select this and I put in a matrix, it will output my eigenvalues. And if I select this and put in a value, for instance my matrix A, I should be able to get my eigenvectors. Alright, so now I have some eigenvectors that I've outputted. Now, how do I interpret these eigenvectors? Well, I'm looking at the columns of these values will give me the eigenvectors. So I have an eigenvector of 1, 0 is my first eigenvector. And my next eigenvector would be negative 0.857493 and 0.514496. Now these are some ugly values here, but it's really just the relationship between these two that's important. Because remember, any multiple of an eigenvector is also an eigenvector. So it's likely that I could scale these to find a nicer value for one of them. Now, what if I want to take eigenvectors of a different matrix? So I want to modify A here. So now I'm going to go to Apps. I'm going to go to 6 to pull up my matrix editor, except this time I'm going to open an existing one. So now I'm going to open a matrix, and I'm going to open the value A. This is the matrix I want to open. Now here's the one that I previously typed in. I'm going to modify this a little bit. I'm going to go 1, negative 2, and 2, and 1. So this is going to be my new matrix A. I will quit out of here and once again rerun eigenvectors of A. I'm going to get non-real results. This tells me that while I'll have eigenvectors, they will both be complex. So now what do I do? Well, to deal with the non-real results, first I'll have to escape to get rid of this error message. After that, I'm going to go to Mode, and I'm going to scroll down until I see the complex format. Right now I can see that it's set to just output real numbers or work with real numbers. If I go over here, it gives me the option of switching to complex format. I can either get those outputs displayed in rectangular complex form or polar. I'll go to rectangular. So once I adjust this and hit enter again to save, now if I rerun this command, now it will spit out those complex eigenvalues. And furthermore, I should be able to go to Math once again, and 4 for matrix, and then scroll all the way down to eigenvectors. I should be able to select the eigenvectors of A, and get this result as well. Once again, we should be careful about reading this output. Here I have the columns of the output as the actual eigenvectors, and the first output I see is negative 7. The first one I see is 0.707107, and then negative 0.707107i. I can see these are really essentially the same value.
So I took this vector, and because any multiple of an eigenvector is also an eigenvector, if I divide it through this whole vector by 0.707107, I can see that first vector would really be 1, negative I is the vector. And this other eigenvector would be 1 and I. So those would be my two eigenvectors. You should also note that sometimes these values can display and roll off the screen, and you should be able to put your cursor up here and move your cursor over if you wanted to see more of the output. So that's how you deal with complex eigenvectors and eigenvalues. And that concludes this period of instruction. Thank you.
Alright, so hopefully we've given you enough to get started on using your TI89 to do linear algebra. But once again, always the best way to learn is to dig into it and try to play around. Go through some of those menus and see if you can find some of the syntax. If you have trouble and are looking for different syntax issues, your best bet is really to go to Google. Just Google the problems you're having and likely you'll find some help. Alright, that concludes this video. Thank you.